Hi, I'm going to show you the economic model to evaluate different reproductive programs. This particular program has both estrus detection and timed artificial insemination. For this particular model that we're going to show you today, we have, for example, compliance shot. That's the compliance with injections, and right now it's set for 95%. And this model, as I said, combines timed artificial insemination with estrus detection. So I have accurate estrus detection, right now it's set up for 57%, and inaccurate estrus detection is set up for 3%, for a total of 60%. And I also set my conception rate, in this case 33.9%. For the economic calculations, I have my inputs, such as heat detection cost. It costs about 15 cents per cow per day. Cost for AI semen cost, that's $10 per straw. Costs $5 to inseminate a cow. If I have to purchase a replacement heifer, it costs me $1,600. Other costs per day are set to 2.250. Feeding dry cows costs me 15 cents per kilogram of dry matter, and feeding lactating cows costs me 25 cents per kilogram of dry matter. For this particular model, the milk price was set to 44 cents per kilogram, and if I have to sell a cow, I'm going to sell for 65 cents per kilogram. Each calf produced is going to generate $140 in income. Also, I have the cost for my hormones. I have prostaglandin at 265, GnRH at 240. Each injection is going to cost me 25 cents to give the injection. And to diagnose my cows, if they're pregnant or open, it's going to cost me $3 per cow. And I can adjust milk production, but right now I just have it set at 1. I'm not increasing or decreasing milk production. And stillbirth rate set at 6.5. This model is very flexible. You can add as many inputs as you want, and you may add the slider boxes to change the cost or any parameters that you would like. Now let's see the outputs. I can add graphs to evaluate my outcomes at real time. So I have here cow numbers on the right of the screen. I can look at mortality and cooling. I can look at my incomes and cost. Right here I have my average milk production per cow and economics, the total profit per cow per day. And here is going to see my cow numbers, cow percentages. I'll see the number of open cows, pregnant cows, number there in voluntary waiting period, number are milking, and number are dry. And here I have the speed in which I want the model to run. Right now I have it normal speed. And I should have said that this in the beginning. This is a model using the NetLogo platform and developed in collaboration from University of Florida and Ohio State University. Right now I'm going to set up. I have 1,000 cows. So I'm going to create my cows right now. Set up. There they are. They're all black, which they are all open. And they change colors. So I'm going to hit go, and things are going to start happening. There they are. I'm going to hit go again. I'm going to stop. Just to show you. So they are bred first time at 72 days in milk, and I can see here that 33% got pregnant after the first breeding. So that's the timed AI. They're all timed AI for the first breeding. Then after that they start returning into estrus following a 21-day normal distribution. So here they are bred upon estrus detection, and then here 42 days later I can see there is another spike here. They're bred again. The cows that were not bred Upon astral detection, they are timed artificially inseminated again. So 72 plus 42, that's 114 days. So that's when they're timed AI again. Then it continues like that. I'm gonna hit go again, and the model is gonna keep running. So I can see my economics. I'm gonna hit go here just to show you one thing. So when I inseminate all those cows at timed AI, there is a big drop in profit because I'm spending a lot of money breeding those cows. So I had a loss of about $6 per cow in that specific day. But what really matters is the average income. But that day I had a big loss right there at 72 days. And here you can see my milk production and the lactation curve, as you can expect. So they all start on the first day in milk, and here's the expected average milk production for the herd at this point. I'm gonna hit go again, and the model is gonna keep running. I stopped again just to show you. Here there's a big increase in income at 352 days. And this is when my cows, a lot of them calved after getting pregnant here. So there is an increase on the calves. You know, I'm gonna sell a lot of calves here. So this is going to increase my profit in that specific day. I'm going to hit go again, let the model run. There it is. Now let me show you. I had another big loss here at 450 days in milk, and that's when I set up my model to sell the open cows that did not get pregnant up to 450 days in milk. So they're here. There is a big loss because I have to spend a lot of money with replacement heifers. So I lost about $73 per cow on that specific day. Gonna hit go again, and now I'm gonna speed up the model so things are gonna happen quicker. I'm gonna let the model stabilize. You can see that after about 2,000 days, my model has reached a steady state. So there is minimal variation, normal variation, because this is a stochastic model. So there are deaths and purchases, and cows going dry and cows calving every day. So there is change, but now the model has decreased, has stabilized. So we don't see these big swings in the proportion of cows anymore. So red here is milking. Right now we're milking about, let me see here, 87% of the herd. And this particular model, pregnant, is blue here, and I have about 61% of the herd pregnant. Just open cows, 40%. These are complementary, so I have 60 here, I have 40 here, and about 17 are milking during the voluntary waiting period, and 13% dry. So I had 87% lactating, I have 13% dry. If I let the model run for a couple more days,